And I'm going to use the opportunity to invite Taroon on stage. Taroon's the Senior Vice President and the Head of all Engineering Products at Atlassian. And what we're going to talk about, and the reason this topic comes in, is because we've been, like we just spoke about machine intelligence, right? Human beings getting ready, machines getting ready. But is engineering ready? The way we build our products, is that up for snuff? Is that going to change? So that's the topic that we're going to talk about, right? So welcome, Taroon.
Thank you.
I think I'm going to kickstart by, the first thing that I wrote down saying, traditionally, almost all engineering products that we have built, especially some that your organization makes for us, for the tech world, have been around collaboration. But collaboration, the traditional principles of product engineering when it comes to collaboration are changing, right? The modern design principles are different. They're supposed to be we were speaking about telemetry, a lot of those things have to change. So how do you see those product engineering fundamentals change in this new world?
Yeah, no, great question. So I think some fundamentals of building products don't change. Like I think one of the things that I would go back and say data is very critical. I mean, I'm a product engineer, and oftentimes like we want to lean in very heavily in data. We want to build products with a very strong data mindset. And in the case of AI, it becomes even more critical because I think you guys were talking in the previous session about unpredictability of responses and things like that. So one of the things I would go back and say, look at your engineering teams and say if they're really data literate. Of course, every organization, every product is using data. But oftentimes, when you actually look deeper, the things or the questions I ask my engineering teams is telemetry, is instrumentation part of your building the product? Like when you actually go put a feature out, are you able to reason it in terms of data? Do you have the right tools and enablement where that is easy and that's part of product building? And also when you make decisions, not just macro decisions, micro decisions, are you using data for that? Like when you talk about a particular feature, are you referencing data as a reason to build it or not build it? Are you making decisions using that? And how easy it is for an engineer to not depend on a data engineer, but like an engineer can go back and get insights back from the product. So one part I would say product engineering has to be ready in terms of very strong data skills, which is needed everywhere. The second part I would go back and say, I mean, we've been talking about AI since morning. So I think in this current world, both, like there are two folds. One is how are the product engineering teams or engineering teams in general are leveraging AI to make themselves more efficient and better at building products. And the second one is how they're incorporating AI back into the products that they're building. So when it comes to leveraging it for themselves, like I know teams are using Copilot or Cursor or other sort of code completion tools, but when you look at an engineering team, and typically in the collaboration setup, as you said, I kind of think of three stages: left of code, code, and right of code. Left of code is all the time that goes in terms of understanding, figuring out what you need to build. You collaborate with other people, you look at data, you look at research, you look at your own intuition, and then you figure out what you need to build. Code is the act of building, which is more about, of course, writing code, deploying code, testing code. And then the right of code is more the services and the products that you have in the market. How do you actually support them? How do you manage them? How do you iterate on them? So looking through this entire life cycle and figuring out how and where your teams are prepared to leverage AI to do a better job of that. Of course, I work at Atlassian, so we kind of look at the entire journey of software development life cycle. So that's the second part. I think you got to get your teams ready for becoming productive. And then lastly, when I talk about incorporating AI into your products, I think you have to still stay very grounded in what problem you are trying to solve. And when you describe that, think without technology, think from a user perspective. What is that one thing or that use case you're going after? But then think very hard how AI can make that better. Do you have some unique data? Can you leverage that data to enable something with AI that you may not be thinking about previously?
And I was just reflecting on what you're thinking. I think one of the modern agile tenets that we've always had is fail fast, right? Quickly, fail fast, move on, build on, learn from your failures and so on. But in the modern world, sometimes failing is expensive, and it is probably getting slightly more expensive as time goes by, right? So the cost of failure sometimes means that fail fast has got to be viewed within a certain, especially from a product lens, because if you're innovating, if there's the first MVPs come out, you realize that really off the mark on the first MVP, agile principles say that, of course, you've got to move on, learn from it, put it back into your backlog, get back. But it takes time. Sometimes in a very fast innovation edge, it just sometimes can get in the way, especially for some of the startups out here. I was having a chat with another, and they feel, one of the colleagues was telling me that they have a great product, but halfway through the product development lifecycle, they realized that that product needed to be changed. So there was a bit of a costly, expensive error that was coming in. How do we plan for that? What's your observation? In your experience, how do we keep an eye on that?
Yeah. So I think I kind of think of in terms of learning loops. And learning loops is where you have an idea of, it's well grounded in data and research and your intuition. You take it in front of users, you figure out how people are interacting with it, is it doing what you expect it to do, and learn from that and iterate. So I do think for a product engineering team, you have to really maximize the number of learning loops that you can have. The more the learning loops, the faster you, the better the product is. And the faster you can get at these learning loops, the faster time to market, time to a good product exists. Now, in terms of failing fast, to your question, I kind of think of minimal testable product, not even an MVP, but more like what is the absolute minimum that you can actually put out in the market, learn from it, or put out in front of your users, learn from it and iterate from it. So oftentimes you have to think very hard. You don't need to build the entire thing. Think of that absolute minimum you need to do. You also have to go think in terms of who you want to test it on. Like, for instance, we are, we serve software teams. We are in the DevOps space. We are building a number of AI tools actually to automate / incorporate AI into various aspects of SDLC. Before we go test it with our customers, we are actually running these tools inside our company because that ring of people, I think, has far more tolerance in terms of an incomplete or not a fully baked product. So that's your first line of defense. And then even when we go out, we test it with a small set of users, get that feedback and continuously iterate, and then you keep expanding the number of people you are exposing to. And for me, experimentation is your friend. You want to do the minimum size experimentation, make sure your hypothesis is clear. Sometimes you also waste time because your hypothesis is not clear. You're not very principled in terms of what you're trying to test and how you're going to understand from the metrics whether you succeeded or not. So the little bit of discipline and principles in the beginning can go a long way in terms of minimizing your costs. And lastly, I would say, some waste will happen. Like, I think at the same time, failures, like, the good thing is you learn from it, but there once in a while you'll have failed experiments. The important thing is what you learn from them.
Yeah, you know what, I just want to dwell on that, right? I mean, I'm sure there are many of us here who are engineers or technologists, and this is a dilemma for the engineering teams because I like the I like the word that you coined, right? Minimal testable product instead of minimum viable product. Now, if you do too many minimal testable product, MTP1, MTP2, to coin that, the challenge is going to take time. You're right. The cost of failure reduces, but cost of time goes up, right? Your ability, time to market goes up. Isn't that a dilemma? I mean, would net, it's all cost?
Yes and no. I may push back slightly on that. So I do think, look, when you push something out to everybody, the bar is very high. The design bar is high, the engineering bar is high, the supportability bar is high. So I do think when you think of a minimal testable product, in some sense, you need to lower that bar. I often, in my company where I work, we have this constant debate with our design team. We're saying this is an experiment. It's only going to go to 2% of customers. You don't need to hold the same bar that you put for 100% of your customers. Similarly, you don't need to prep your support teams because you're really going in a very controlled fashion. Even within that, we have a sense of who are more sensitive customers where we actually would not take out an experiment. So yes, I think it takes time, but there are sort of techniques through which you can reduce this. And lastly, I think if you still have to be fast. So any kind of investment you are doing in terms of increasing the speed of your organization, increasing the speed of your learning, every loop that you're doing is actually faster, so that helps as well.
Fair enough. And plus there's a learning curve that will just kick in, right? The teams get better at doing that. Fair enough. I think that's a good answer. Thanks for that. The other thing was the concept of rapid innovation, right? Now, one of the things that all product engineering firms are now facing, especially the ones who are in the product space, is that they build a release, the release is out, and then there are way too many changes that happen in the external world, which means that it's back to the drawing board. Might not be completely, but in terms of feature set, benchmarking that they need to do, and so on. So rapid innovation has its pros, but if you have a certain high release frequency, then there's always a risk that you run into errors again, going back to the discussion that we had. That's again a bit of a very nuanced area, isn't it? How would people resolve that?
I think actually the rapid innovation in my mind, or if your product ran out of product market fit, maybe that's what you're saying. You put something out, it was relevant, and now it's slowly starting to get out of product market fit because the situation is changing. I actually think rapid is good because you find out faster that, hey, this stuff is no longer valid. Let me go back to my first point, which was more around you do want your products instrumented. You want to even know that this stuff is engagement is going down, adoption is going down, and you want to catch it much sooner than later. So in that sense, it goes back to the earlier point about make sure your products are fully instrumented. And you are actually getting that signal. You're not keeping your eyes off from engagement, from the metrics, key metrics that you care about. And at some point, when you do realize from that data that, hey, stuff is changing or your environment is changing, you need to go back and react to that. And even in terms of reacting, it's not that you need to throw away a product and then put in another full product out there. Oftentimes, those are iterative changes on top of your existing product. You might, again, push it down as an experiment on a cohort, see if that change actually addresses something that you were noticing. So I still, look, I worked at Facebook for 6 years. So for me, like moving fast, it's very hard to take it out of the DNA. So I actually value speed quite a bit. It's a virtue. And also kind of coupling it with strong feedback and iterating is helpful. In certain industries, you cannot move very fast. I work on SaaS products now, so you have to be a bit more careful, especially if you're running mission critical sort of products. But at the same time, as long as you are strong on data, you are optimizing for speed. You're watching, keeping your ear to how your products are used and have that muscle to go back and fix fast. I think you can actually keep your products relevant.
Yeah. I'll go to give you one last question, and probably if you have time, we'll take one question from the audience. 2025, Feb 2025 now. So Feb 2022 and Feb 2028, 3 years behind us and 3 years ahead of us. What would be the one single biggest change in terms of a product manager's skill that would have changed in the 6 years, from Feb 2022 to Feb 2028? One.
Oh. Okay, that's a tough one. I wish I had that fortune cookie thing that came earlier.
It's right there.
I think in many ways, one big change from 2022, and you're assuming that ChatGPT moment, I actually think everybody started out with defense in many ways, like how do I respond? How do I do basics to make sure I'm relevant? 2028, and actually much sooner than that, I would think it's more offense with AI. It's more about how I actually create a much better product, solve a problem that previously I wasn't able to solve. And in many ways, how do I differentiate myself through AI as opposed to just trying to defend? So I think you'll switch from being defense to offense is what I would say.
Got it. We've got a minute and a half left. If there's one question that I can take from the audience.
Very practical responses to some of the pressing problems we see. One question, you talked about minimal testable product, right? And you also said to be testing it in loops. Mostly hypothesis is tested during the TRL 0 to, say, 3, and customer comes in by 4. So how do you actually sure that the hypothesis is correct in the earlier stages, the technology readiness levels?
Let me understand your question. Sorry, one clarification. You're saying sorry.
I'm talking of technology readiness levels, TRLs. Yeah. So when we are looking at hypothesis validation, usually the users are not there, right? And the customer usually comes from TRL 4 onwards. So how do you make sure your hypothesis is tested well?
Yes, that's a great question. So I think there are stages, and I almost feel like you have some customers at every stage. Like, especially if you're building a product and if you're dog fooding it. Let's say, in our case, we do build products which are for software teams or for general knowledge workers, and we have a company of 13,000 folks. So very first, as they are using the product, we are actually getting some signal back. So I would not go back and say we have some customers. Obviously, our own company is customer 0. After that, you could have programs. We run something called early access programs. Different companies have different versions, where you might opt in. You might sort of partner with a small set of customers who are willing to test your product with, of course, all the caveats and risks. And then you go into beta, and then you go into experiments with other customers. But at every stage, you do have a set of customers you are working with. Now, prior to that, if you have 0 customers, then you need to very heavily rely on the past, which means either go back and look at your data and see you can extrapolate from that, or you do a lot of very strong user research, which is where you're talking to the hypotheticals to go back and validate. And my point with all of this is you need to be prepared to say these are experiments. You're going to almost treat it like an experiment, and when you go to the field, you might see something very different, and be prepared to change your approach or revise your hypothesis.
Thank you. Thanks a lot.